First of all, happy 51st moon landing day, everybody, and welcome to Vaisalan and the Finnish Meteorological Institute's webcast. We're here to talk about space-proof measurement technology, which is soon heading to Mars on board NASA's next rover, the Perseverance. And I personally anticipate quite interesting insights from our experts today on why, what, and how did they end up going to space, and much more. In the studio, we have representatives from two Finnish organizations which are sort of hitchhiking the lift to the red planet. From the Finnish Meteorological Institute, Maria Gentzer, heading the planetary and space research, and Maria Hieta, who works there as a research engineer. And from Vaisala, we have Lisa Åström, who's in charge of Vaisala's product and technology development. So welcome to all of you.
Thank you.
In addition to the people present here in the studio, we have a very special guest speaker with us today who will share his thoughts about space later on in this webcast. But now, note to all of you, our webcast viewers, remember to use the social media channels and use the hashtag SpaceTechFI and enjoy the ride. Now, let's start. First of all, Maria Gentzer, tell me, what does Finnish Meteorological Institute has to do with space research?
Well, the four major fields of expertise of the Finnish Meteorological Institute are weather, climate, sea, and space.
Right.
So most people know us at least about our weather predictions, but we also do much more. So we do monitoring and research and providing services in all of these four fields, including space.
So, well, now I understand that Finnish Meteorological Institute is sort of like a very top-notch, world-class in space research. Is that right?
Yes, that's true. So we have, for example, in Sodankylä, we have our Arctic Space Center where we receive the data from satellites and make data products from those. Then we do planetary research. Especially, we concentrate on the atmospheres of Earth-like planets like Mars. Wow. And we also monitor the space weather and provide space weather alerts, for example, for air traffic. So we actually do quite a lot related to space.
Very cool. That's very cool. What about Vaisala?
Vaisala specializes in weather, environmental and industrial measurements. So we're all about the measurements behind weather forecasts or the weather or the measurements that give good insight to industry processes, for example. So that's our role, and we've been very keen on innovation all our existence, and find that technology development gives a good basis to solve the problems of our customers, but also give something to the society in general. And
I would say, like, sorry to interrupt, but for the general audience, me personally, I have now studied quite a bit of Vaisala and what you guys do, but if you would very shortly tell people, the viewers, like, what does Vaisala do?
Vaisala does measurement products and to the very tough environments. For example, in weather observations, we have products that go inside a hurricane to measure the conditions of a hurricane.
Right.
And you could see our products on airports of the world. We are market leader in weather observation systems for airports. And then we are in tough industrial environments. To name a few, you could find our products inside power transformers, or we are also involved in vaccine development of the most critical pharmaceutical sector.
We can be, as Finns, can be very proud of that company. It's doing amazing work. And you mentioned that in very, very demanding circumstances and environments, such as space.
Well, absolutely, yeah, a definite extreme case, but yes, we strive for the difficult measurements.
Wow. So let's hear a bit more about that, these difficult circumstances, and we're going to hear more about that from our very special guest speaker, because he is a former NASA astronaut himself, and this is a great privilege to introduce you to Mr. Mike Massimino. Welcome to the show, sir.
Hi, Mike Massimino. Thank you very much for having me. It's my pleasure to be here to celebrate this wonderful event that's coming up and maybe shed some light on the perspective of someone who's actually been to space. I was a NASA astronaut for a little over 18 years, got to fly to space twice.
That sounds very well, it sounds awesome, if I may. And we're, again, very, very happy and honored to have you with us during these very exciting times. It's cool to have you with us on the show. You have your own experience from space, Mike, as you mentioned. Could you please tell us a bit more of that? What is it like?
Well, again, thanks for having me. It's my honor to be here. This is really quite an event to be a part of. My experiences were flying on the space shuttle to the Hubble Space Telescope. The Hubble Space Telescope is in orbit. It's still working. And the last time we were there to work on it was 11 years ago. That was my last time into space. But it's still working, and it takes amazing images of our universe. And I think similar to the way the Mars rover, that program, and what's coming up with the new rover, it's about science. It's about understanding our universe. And as an astronaut, my role in that was to fly to the Hubble Space Telescope and be a spacewalker. So most of my training to get ready for those flights, and also what I concentrated the most on for those flights. You concentrate on lots of things, but I was a spacewalker, getting outside in my spacesuit and working with tools to repair and upgrade the telescope. So that was my job while I was at NASA. It was the best job in the world.
I bet it is, and it was. And to be totally honest, I always wanted to be an astronaut. I'm probably not the only guy in the world who wanted to be an astronaut and push those earthly barriers, but maybe one day, who knows? Mike, according to your extensive experience, how would you characterize space? What is it like? Is it so demanding as we assume?
It is. Space is a very challenging place to exist, to live, and to work in, and to just fly any type of spacecraft because of the conditions in space. So I teach a class in spaceflight at Columbia. I teach a couple classes. I'm a university professor, and what I try to tell the students, no matter where they're going to go after they graduate, they're going to have to solve complex problems. I can't think of any environment that makes it more challenging to solve any engineering problem than in space, because you have so many different conditions that are at the extreme compared to what we deal with on Earth. For example, temperature. We kind of have a range of temperatures. It can get cold, it can get warm on our planet. But in space, it can get really hot in the sun, a couple hundred degrees Fahrenheit. It can get really cold in the darkness, a couple hundred degrees below Fahrenheit, so below 0 Fahrenheit. So you have this extreme of hot and cold that you have to worry about. The spacecraft, the part of the spacecraft in the sun is going to get really hot. This part of the spacecraft in the shade is going to get really cold. There's a huge amount of radiation up there. Our atmosphere and our radiation belt, our radiation belt, our magnetic field protects us, absorbs a lot of that radiation, so we don't get all the harmful effects of being in a radiation environment. We're protected from it. So be careful when we go out in the sun. But in space, you're unprotected, so you get hit with a lot of cosmic rays, a lot of radiation. The launch itself is probably the most challenging part because there's a lot of violence, a lot of shaking, G-forces, and whatever you build to put inside of that spaceship has to be able to survive that, whether it's a person, like when I was there, or a spacecraft like we're going to be dealing with the launch to Mars. That has to survive all that vibration, all that acceleration, all that G-force just to get to space. And then it's going to be there in zero gravity. So it's not going to have any gravity field to help. And gravity does help a lot of times. It keeps things stable. In zero gravity, things can float around. And then once the distance it's going, communication's important. They're going to have to be able to land and operate and so on. There's so many things that can happen. But that's just some of the things. The large distances, the communication delay, radiation, the extreme temperatures, vibrations of the launch. All these things making a spacecraft work much more difficult than anything you can imagine on Earth. I'm convinced of it.
Yeah, well, it certainly sounds like a tough place to be for a human being, but also for the equipment, right?
Right now, it doesn't sound like much fun, but there's a lot of excitement. You go through all these things. It's a for an engineer, it's a wonderful thing to be able to work on a project like that. For your engineers and all the engineers that are working on this and the scientists involved, this is kind of the dream of a lifetime to get to work on a project like this. It's very difficult to fly something in space, but it's also very rewarding because of that challenge. And when it works, it's extraordinary.
Well, it certainly sounds like it. And Maria Hieta, as an engineer and a scientist, Do you share that feeling that Mike was just mentioning and explaining? Has this project been sort of like a dream of a lifetime for you?
Yes, it really has. It still feels unreal that our devices will soon be roving on another planet.
Yeah.
And it has been really challenging and demanding, but like Mike said, also very rewarding.
Tell us like one more time, I don't know, we've been probably talking about this over and over again. We know through Curiosity rover already why to Mars, but please explain us again why Mars. What are we looking for from there?
Yeah, so Mars and Earth are like sister planets, but they have evolved to be very different that we see now. So Mars is really cold and has a very thin atmosphere that's made of carbon dioxide. But for the planetary reasons make the atmosphere behave very similarly. The rotation of the planets and the seasons make it the atmosphere dynamics to be very similar on Mars as also on Earth. And so by studying Mars, we can actually learn something about Earth also. And if we are going to send people on Mars, we have to have the accurate weather information because there's, for example, huge dust storms that can cover the whole planet.
Makes sense, and I'm sure there are lots of eager scientific partners willing to go to space. Can you tell me why FMI and Vaisalan are going there? Why did NASA choose you?
Well, we have already years of experience in designing and building space instruments that are very light, very small, consume very little power, and all of these are very important aspects when you go to space because every watt counts and every gram counts. And we have done a lot of collaboration with Vaisalan, very fruitful collaboration, and we have already proven that we can do these instruments, so that's why NASA chose us again.
Cooperation is key to success in many big projects, and next, let's get a bit more techie and talk about space-proof technology. So what are we or you taking to Mars and why? Let's start with Finnish Meteorological Institute. What are we taking there?
So we are taking, first of all, humidity sensor, relative humidity sensor, almost the same instrument as we have now on board Curiosity rover.
So that's it?
That's it,
okay.
Yes. And that's already in the picture. And then we are taking the pressure sensor too. That's also almost the same as in the Curiosity rover. So pressure and humidity sensors based on Vaisalan sensor technology are our main devices that we usually take to Mars.
Okay. You mentioned MEDA. What is it all about?
Yeah, MEDA is the instrument suite that is the weather station plus some dust monitoring and solar radiance monitoring on Mars. So our sensors are part of MEDA. MEDA stands for Mars Environmental Dynamics Analyzer. And in addition to our sensors, it has, for example, temperature sensors, a wind sensor to measure the wind speed and wind direction, and then also there's dust monitoring and solar radiation monitoring.
Where in the rover? Where are these devices located in?
Well, the humidity sensor is located on the neck of the rover, below the cameras.
And the rover is sort of like a small car.
Yeah.
Okay.
Yeah, it's the size of a car, and so the humidity sensors can be seen now below the wind sensor there on the neck, and then our pressure sensor is located inside the rover in a warm compartment where the temperature is nice and stable, and only a little pipe protrudes through the deck of the rover to sample the atmosphere.
Okay, and about the Vaisalan sensors in this MEDA instruments, can you, Lisa, tell us a bit more about that? Are they specifically developed for space?
In fact, the sensors inside those instruments that Maria showed are standard sensors that we use in many applications, both meteorological and industrial. The humidity sensor is quite the standard one, and the pressure sensor is slightly toned as the pressure on Mars is lower than on Earth. But the technology is the same in both.
On Earth, where could you use this technology?
Well, those would be used, for example, in weather stations, in radio sondes, also in industrial processes, for example, on the semiconductor side, or to name a few simple examples, even greenhouses and data centers would have humidity monitoring and control typically.
Okay, it must be a silly question, but since I don't know this, I'm going to ask to put it simply. Let's say it's kind of a standard technology, as you're saying, but let's say that something goes wrong at Cape Canaveral, a NASA engineer could go to the next door greenhouse and get the sensor and install that to the rover, no?
Well, in principle, he or she, I guess, could, because it's the same technology as mentioned. But of course, well, it's NASA and it's part of a big equipment, so there would probably be things to be done in between. But it is the basic quality is the same as we provide to any of our customers who would have a humidity sensor. So in principle, you could do that. What do you think?
Yeah, so basically the sensor head is standard, but the rest of the device is custom made, and also all the electronics needed to read the sensors. So these are really handmade for each mission.
Right.
Every material and every component needs to be tested for space use and these hard conditions, and the whole instrument is calibrated and tested for Mars and for this mission.
Of course, I believe.
And in case anything goes wrong in Cape Canaveral, we do have spare models of these instruments.
Good to know. One would probably have that. Very, very big and important projects. And it's very, very exciting, all of this. So all of this is installed on Mars Perseverance rover and much more. Maria, can you walk us through a little bit, like what else is involved? What does the rover carry altogether?
Yeah, so the rover carries a large set of scientific instruments. So, for example, there are, first of all, there is a mast cam, which is kind of the eyes of the rover with a very good eyesight. It can do stereo imaging, it can do high-definition video, it can look very far and zoom, so it can find the interesting objects for the rover to examine. Then next to it is SuperCam, which is a camera capable of determining chemical composition of the objects, like rocks, for example. It also has a laser, which it can use, for example, to clean off dust of rocks that are far away, so it can take a look what's below the dust.
Right.
Then,
with laser?
With the laser,
all right.
Yeah. Then on this kind of hand of the rover, there's Sherlock and Pixel. So Sherlock is a UV spectrometer that can search for organic components, and it even has a little magnifying glass, just like
Sherlock,
a Sherlock would. So it kind of does forensics and searches for organic components. And then,
sorry to interrupt, but looking at the picture, it also says that does it have a sidekick, like called Watson?
No, Watson is not there, but there's Pixel. Pixel is an X-ray spectrometer, and also used for determining the composition of materials found on Mars. Then there's MOXIE. MOXIE is a very cool experiment. It's makes oxygen from the carbon dioxide that is very abundant in the Martian atmosphere. So that's like a technological experiment where NASA tries to actually manufacture oxygen from carbon dioxide. And then there's RIMFAX, is a ground-penetrating radar, so it can look below the Martian surface and look what's below, what kind of structures are there. It can see if there is water, if there's ice, if there are brines present. And then something else which is not shown on this picture is a helicopter. So
a helicopter?
Yeah. So there's also a small technological experiment, a helicopter, that will be the first controllably flying object on any other planet. So that's the first time NASA or any like human-made object is going to actually fly in a controlled manner in Martian atmosphere.
Who flies that? Is it a drone or a helicopter? What do you call it?
Well, I think it's called helicopter.
Yeah?
Well, NASA flies it, but not in live, because there is
Right.
such a big delay in the signals between Mars and Earth. So you cannot.
What's the delay, by the way?
It's several minutes. So you can't just fly it like live, but you can give it commands, so it can do pre-programmed operations like detaching itself from the rover and then flying away from it and then coming back to recharge itself. So that will be very exciting when we will have the first helicopter flying.
Certainly sounds like it. Sounds like the rover is a compelling set, as we saw from the image, kind of like a laboratory on wheels, if you may. Trusting the equipment, that's incremental, and even the smallest things matter. Or what do you say, Mike?
All the little details are important, no matter what they are. Because if just one thing goes wrong, you could be totally out of luck. We've had situations like on the Hubble Space Telescope. We had a scientific instrument, a spectrograph, that was able to detect the atmospheres of far-off planets. It was an amazing instrument, and it failed because it had a short inside, an electrical short, that failed the power supply. So the power supply was gone. It didn't matter that we had this wonderful instrument in space. It didn't work because you couldn't turn it on. And it's in space, so you can't get there very easily. We devised a spacewalk to go up there and fix it. But it goes to show you that just one little failure can take down the whole system. Every sensor needs to work. Any one of these systems, whether it's cooling, power, communication, navigation, all of it has to work precisely. And if one of those things does not work the way it's supposed to, you could lose the whole mission.
That certainly put things into right perspective. So the rover is approximately the size of a small car, as we agreed. The FMI's instrumentation right here, for example, can fit on the palm of my hand. But the sensors itself that you have there, Lisa, they are the size of a pencil eraser, or what would you say?
Pretty much so, yeah. So here we have in the frame is a wafer of the pressure sensors. So that wafer is the entity where we produce them in our clean room. But one wafer has 150 pieces of pressure sensors here. So really the one sensor is, like you say, the rubber of your pencil. It's very small. It's kind of miniature microsensor technology.
Okay, how do you do it? How are you able to do that?
Microsensor technology is a very demanding field, and it's not for the hasty-minded, let's put it that way. The technology, yes. For example, the humidity sensor, the HumiCap here, has been developed since it was introduced in 1973 and continuously improved after that. And then the barocap sensor, which is the pressure sensor heading to Mars now, that was developed in the 1980s. So typically the development really takes commitment, takes talent, capability of people to drive theory into prototypes, but also takes the need to be able to manufacture in demanding, very, very precise operations in a clean room setting. Vaisala, for example, we invest a lot into research and development. Last year, 2019, we invested 13% of net sales into research and development. So that's quite a high intensity, and 22% of our personnel work in research and development. So all in all, it takes kind of vision and long-term commitment from a company to be in this field and continuously improved sensor technology. Also, we have our own clean room facility. That's super important, because then we have our researchers and the capability and the skills of our clean room team working side by side every day, and only then you get the kind of continuous iteration and development loops that you need to really get to the perfection and kind of build a solid technological competitive edge, which takes time to get, but on the other hand, it's not lost easily, so it builds a solid strength for the company for sure.
So we have now identified that it's been a long development process from both FMI and Vaisala. But next, we're going to hear some insights on the demands the technology in space has from our astronaut, Mike Massimino. Mike, go ahead. Mike, so what needs to be taken into account when taking technology to Mars?
Mars is a lot further away than any place we've sent people. We've sent, my missions were in low Earth orbit, 350 miles above the Earth. The space station is 250 miles above the Earth. The moon is 250,000 miles away. But Mars is a lot further. If you think of it in far as time goes, to get to the space station takes a few hours. To get to the moon takes about a day and a half. To get to Mars is going to take 6 months. And during the shortest time that you can get there, it's going to take 6. So it's a long. And the other way to look at the distance is in communication. So to talk to the space station, it's a pretty quick, just maybe a second or so that you can ask a question and get a response. When you're on the moon, it's a couple seconds, about 3-second delay, ask a question. On Mars, it's about 20 minutes, 20 to 30 minutes by the time a signal goes to the spacecraft and comes back when it's on Mars. So these distances are not just physical distances that it takes time to cross, but also to communicate. So because of that, when you send something to Mars, unlike when we send something on this International Space Station, or when you send something to the moon or closer by, you can't get to it, and there's nobody to help. The advantage we have with people in the loop is that they can take care of things if they break, if something needs to be done, if we forgot about something, we can try to fix it with people. Not only does going to Mars take that away, we can't have people there to help, but also the great distance that it is, that spacecraft has to work. Everything has to work. And if it doesn't work on its own, there's no repairman that can go there and take care of it. So, or repairwoman to go there and take care of it. You're out of luck. So everything has to work, and it's very unforgiving. It's not like what we deal with. You can think of lots of things that don't work. A building might not be perfect. A car may not be perfect. Whatever project you're working on might not be perfect, but you have the ability to try to learn from it and fix it. You have to learn everything you can before you send something to Mars, and it all has to work, or else all that work, all those years, all that money that went into it it goes to waste unless everything works, and it makes it very challenging because of the distance. We talked about the radiation, we talked about the temperature changes, but also that distance. It's so far away, we can't fix it. Once it's out there, it's got to work.
So you would imagine that its durability and reliability, those are the key factors playing a key role in any equipment we send to Mars.
It has to be reliable. Above all else, it has to work. And you don't want to put something into space if you have any question of whether or not it's going to work in this regard. With the Hubble Space Telescope, with the International Space Station, we did the best we could to make sure all the systems would work, of course, but we also had people on board that could help fix things that were wrong. This is not going to be an option when we're going to Mars with this spacecraft. It all has to work. If it doesn't work, we're out of luck.
And how do we ensure that the space-proof technology is also space durable? Both Marias here have visited the Jet Propulsion Laboratory of NASA in Pasadena, California, and the last testing for the equipment was done. What kind of experience was that? Did working in NASA's laboratory differ, and how much it differed from your home office?
Well, it was a great experience, of course. It was very exciting to be there where the magic actually happens and to see all these clean rooms and laboratories where JPL makes their devices. It was a little bit different than working from home because JPL, NASA, they have such big organization. They have lots of people there working on the rover, more than we have here at home. So, and everything is very structured, very planned. So they kind of follow a script where everything is set like minute by minute, all the tests, everything they need to do, and everything is very controlled. But of course, in our lab, we also control what we do.
But NASA is like 100 times more in anything that we do. It's more people, more clean room, bigger equipment, and everything is just much more. Yeah. But the visit for JPL, for example, it was just the tip of the iceberg, that last test of the whole rover. We have been testing for years for this mission, for these instruments. So we test the prototypes, we build many test models, we see if they can endure the vibrations, the shocks, and the extreme temperatures, the vacuum, even before we even decide the final design of the instrument. So it's really a long process to develop something space-proof.
Well, I'm sure it is, and it makes sense and sounds very interesting. Why do we send weather stations to Mars when there's no people there yet?
Well, there are no people yet, but it's still important to know already in advance what's happening with Mars weather, with Mars climate, with Mars atmosphere, so that we know what to prepare for if and when people are finally sent to Mars. But for us at FMI, the most important reason to go on this mission is science. So by comparing the workings of Earth atmosphere and Mars atmosphere, by comparing our two planets, and we can also learn something new about Earth. So that's the comparative planetology, is the scientific reason for us to go to Mars.
Will be very, very interesting to see what we will find from Mars in the upcoming years. But now, in this show, it's time to turn our sights towards the actual launch. So right now, NASA is making the final preparations for the spacecraft launch as we speak. Mike, could you walk us through what all preparations are taking place in the final sprint?
They have a lot of things to think about. They have to make sure that the launch vehicle, the rocket itself, is working, performing the way they hope it's going to work. They're preparing the launch pad, they're preparing the rocket, they're also preparing the payload. Now, they've been working on this for a long time, but it's still the final checks. Did they miss anything? Did everything make it to the Kennedy Space Center in the right? Did everything make it to the Kennedy Space Center in the right condition? Is everything checking out the way they would hope? And they're just going over and over and over again the checklist. And maybe there's some things they want to change, or maybe there's something they want to check a little further, or replace a piece of equipment. Now's the time to do all that. So they want to make sure everything is working, all the backup systems are working, all the primary systems are working, they're communicating with the spaceship the way they expect to be able to, that everything is aligning so that they'll have a successful launch. Some of the things they have to look at too are things like weather and any other conditions that might affect the launch, but they're looking at all that stuff, but they're really concentrating on making sure that the launch vehicle, the rocket, is ready to go, and that the payload, the rover, and all the systems that are on board are all working correctly, and that it'll be ready to go, not just for the launch, but for the long term when it gets to Mars.
Hey, but the spacecraft launch time, it has already been shifted a couple of times. What all can delay the actual liftoff? What are the reasons? Get it back. See, this is the delay. Mike is in Mars right now, so it's a couple of minutes. We have to be patient. Mike, you there? So I asked about the reasons for the delay. I'm getting feedback that we do have a connection to Mike, so he's going to be online now. Mike, you there? There's a technical difficulty. As we see, we have to be very, very sure about all the equipment before we start live shows as well, before we move on. That's why we're testing times and times over and over again. But as we know, and it's very clear that so many things must go right, even in the launch, but with the actual rover and with the testing, with the devices, everything, the amount of time, money, and effort, all parties involved has put into this. It's critical that all details are in place. And the recent SpaceX launch was, for example, postponed due to bad weather conditions. But now let's see what Vaisalan meteorologist Chris Vagaski had to say about the weather factors impacting a spacecraft launch when we talked to him earlier.
Well, there are a number of factors that can impact spacecraft, and each mission has its own weather factors that they are monitoring. And some of those could be as simple as the air temperature or the amount of humidity in the atmosphere, while there are some factors like the amount of wind shear, so the change of wind speed and wind direction with height, or even thunderstorms and lightning. Yeah, so when it comes to lightning, lightning is a significant impact on space launches. It is, of course, very dangerous to anybody that's outside during lightning, and rockets can actually trigger lightning. So as a spacecraft is launched, if there's an electric charge in the atmosphere, that rocket could then cause lightning to occur even if there isn't naturally occurring lightning. And that's happened several times before, for instance, during the Apollo program back in the 1960s, and even last year when a Soyuz rocket was launched in Russia, caused lightning to strike the spacecraft. And that could, of course, cause damage to the mechanics of the aircraft or cause injury to the astronauts that are on board. Yeah, so in May, 2 astronauts were launched from Kennedy Space Center in Florida to go to the International Space Station. And the first attempt at that launch had to be scrubbed, that is canceled, because of the potential for lightning in the area. And on that day, the National Lightning Detection Network that Vaisalan owns and operates detected more than 10,000 lightning events, both in the cloud and between the cloud and the ground, within about 50 kilometers of the launch site. Although lightning had ceased in the immediate vicinity of Kennedy Space Center prior to the launch, there was still a lot of electrical charge in the atmosphere that was detected by the meteorologists at the Kennedy Space Center. And they decided to scrub that launch because of the chance that when the spacecraft was launched, that it could trigger a lightning event.
Thank you very much, Chris. And now we have Mike online. And Mike, I was asking about all the different reasons why the launch for the spacecraft can be delayed. So if you can talk us through that.
Lots of things can delay. Like I used to tell my launch guests when they would come see me launch at the Kennedy Space Center down in Florida in the US, I would say, think like you're going to Florida for a vacation. And maybe you'll get to see a launch if you're lucky. That's the way to think about it. You never know. My very first launch, I went to bed that night thinking I was going to launch into space the next morning. And I woke up that morning, I was, hey, I'm going to get up and have breakfast and put my spacesuit on and go out to the launch pad with my crew and launch. And I call my wife, of course, you know. Call her, hey, I'm so excited I'm going to space. And she's like, what, they didn't tell you? And I go, they didn't tell me what? She says, you're not going anywhere today. I go, hey, this is not a time to kid around. I think I'm going to space today. She says, no, you're not. And what happened overnight, the temperature got unusually low in Florida, below what the limit was. It got below freezing. And they did not, for the shuttle, had this requirement that the temperature could not go below 0 overnight before the launch, because they were worried about the way some of the systems would respond to that. So they canceled the launch while the crew was asleep. So we didn't even know. I woke up thinking I was going. My commander, he didn't know about it either. His wife had to tell him too. So we did not know this was going on, and that's the way it can go. Something can come at the last minute. It could be a drop in temperature. It could be winds. It could be something else with the weather that is really beyond our control. I got stuck in space on the way back too, a couple extra days, but that was a good deal. I really liked that, getting stuck in space a few extra days. That was fun because the weather was bad. We couldn't land at the Kennedy Space Center. So weather's a big factor, but also these other things too, the integrity of the vehicle. We used to scrub also if we felt there was some question we had about some of the systems. If something wasn't performing quite right, we would think that there might be a problem. We would always err on the side of caution, because once you launch and the thing starts to move, you're kind of committed. There are some scenarios where you can recover the payload or the vehicle in some ways, But typically, once you go, that's it. So you have to be really sure that it's going to be a good launch. And we've had them on the launch pad and shut down on the launch pad, and the crew comes out and has to wait for a while to go back. And the same thing happens when there's no people on board. If there's any question, if there's any concern, they're not going to launch. It's better to stay on the ground and wait for another day than to launch and be regretful about it. So the way I look at it is that years from now, people may or may not remember that you delayed. Probably they won't even remember. But if you have an accident, that they'll remember. So it's better to avoid the accident and think about it for a little while on the ground.
Makes sense, absolutely. And it almost like now, if we joke about it a little bit, it sounds like actors in movie business. It's like before you actually see the movie on the silver screen and you are in it, don't say anything, because you never know. Sounds like that. So even earthly measurements matter in space launch. We have actually received also some questions from the audience right now. So let's look at what we have at the moment. First, there's a question for Mike right away. So Mike, and it's not from me, but speaking of movies, this is one of my favorite questions. It sounds silly, but I think it has a meaning behind it. Would Matt Damon really be able to grow potatoes on Mars? Mike.
I don't know. Matt Damon was a pretty smart astronaut. I don't know if I would have been able to figure that out, but the way his character was written, that he was a botanist, and he was able to figure that out. But we have grown lettuce and other plants in space on the space station. We have to figure out a way to grow food in space and on Mars. We have to, because it's so far away. We can't continually supply food and water to a spaceship or all the way to Mars if we want to have people there eventually. So people need, as we talk about all the things that a spacecraft needs to stay alive in space and on Mars, well, people need all that protection from radiation and from the temperature, but they also need air to breathe, and they need food, and they need water and comfort and other things. So it makes it much more difficult to put people there. And the food question of being able to grow food on Mars, we have to be able to solve that. And I think we're pretty close to doing that, and we've made a lot of progress, even of what we've done on the space station. So, growing the potatoes like Matt Damon did, I don't know if we'll do it exactly the way he did it, but I think certainly something like that would be what we would want to be doing. We need to be able to grow food if we're ever going to really explore beyond low Earth orbit, and that goes to the moon as well. We need to figure out a way to grow food on the moon when we go back there as well.
But it's always been so that science fiction has inspired the technology and the science in real life as well. But then there's next question, it goes to Lisa. So for Vaisalan, why do you want to go to Mars? Is it big business for you, they're asking?
Not really. We have our business feet on planet Earth, surely. But it's curiosity that drives us really, and it's a great opportunity also to see, kind of have a testimony of our technology, that if it can survive on Mars, it can be used anywhere, basically. That's a very tough environment, and it's great to see how that goes. And actually we have good experience from the Curiosity rover back in 2012, where we also had our humidity and pressure sensors on board, and it's still providing data. And actually back in 2015 it reported that it had found traces of water, ancient water on Mars. So of course it's good to see your technology there. We're proud to be selected, and it's curiosity that drives us.
But personally, I have to say there are not many companies in the world that can say that it's been tested in Mars.
That's
and
right.
It works. So it's actually pretty good for marketing.
I'm pretty sure it is.
Yeah. Let's hope it works.
Yeah.
And so far it has.
Will work.
And next one, MET Institute. The audience is asking, what was the most challenging part in developing such a device?
Well, there are many challenges. I'd say keeping track of all the little details while still keeping the schedule, because schedules usually tend to slip in these projects, but still you have to keep in mind that you have a launch date, and it better not be postponed.
Yeah.
So there are many tests to run, many details to take care of, many piles, if we still used paper and not electronic devices, I mean electronic files, I would say producing piles and piles of documentation that goes with these sensors. I don't know, would you like to add something?
I would also say that it's the schedule. And we are going through a lot of like destructive tests with the instruments. We are vibrating and shocking them, for example. So basically anything can happen. And we have to always have a plan B, some kind of recovery plan, maybe plan C. So we live in this constant excitement and schedule pressure. So it is challenging.
Especially as you mentioned that with NASA, there's a times 100 personnel and staff and resources and everything. So you have to really, be online with that schedules and those demands. So it's very, very demanding.
Yes, we are only a small part of the big rover, and we cannot be that one small part that delays the whole rover.
Exactly. All right. We also have this one. You have mentioned science several times in the show and highlighted the role of it as the basis for measurement. How do these two connect? Lisa, could you take this one?
The world is not a matter of beliefs, not your beliefs, my beliefs, our cousins' beliefs, or anybody's feelings on Twitter. It's really about science, and I think this is a great program that kind of demonstrates it, that mankind can do still interesting scientific research, and that's how things go forward. That's how technology develops, and the innovations that we get maybe first related to Mars, but probably there comes, or it often has gone that way, that some of the space research has actually ended up in understanding better our own planet and maybe solving some problems here. So that has, I think, is the role of science, and it's not to be undermined.
Then there's one from Mike again. Mike, this goes to you. What was your biggest revelation when you were in space for the first time? I like this question.
It is when getting to space, it's a very magical place to be. It is obviously unlike any other place we've been, that I had been, and it is beautiful. It is interesting. The brightness of the sun, for example, is the brightest light I've ever experienced. The darkness when you're orbiting the planet, when it's nighttime, we're over the planet where the sun is not shining. It is the darkest dark I've ever experienced. You're out orbiting at 17,500 miles an hour. That means 90 minutes for one orbit of the planet, 45 minutes in sunlight, 45 minutes in darkness, 16 sunrises and 16 sunsets in a 24-hour period. Just amazing being there and floating around. But the beauty of our planet is what struck me the most. It looked like looking into heaven. I felt like I was looking into an absolute paradise. And as you're looking at this magnificent view that I had at the Hubble Space Telescope in my spacesuit, I realized the only way that I am able to see this is that I'm wearing a spacesuit to keep me alive. We don't worry so much about the atmosphere. We want to take care of our planet, of course, but we're not constantly thinking about it. When you're in space, you're constantly thinking about the integrity of your life support. Because if it messes up, if something happens to your spacesuit, I mentioned I had a small hole in my glove that didn't go all the way through. There's different layers for the glove, so it wasn't life-threatening. But if something like that happens and would penetrate the pressure bladder, which was just what's holding the oxygen inside, I'd have some trouble, right? So you realize that, and you can look around. I can see the beauty of the Earth, and I can see the vastness of space, and it's unforgiving. You realize we can't live anywhere out there. Where the rover is going, Vaisalan's equipment is going to Mars. People can't live there right now. It's not a place where people can live. It's hard enough for a spacecraft to survive, but people can't go there right now. And you look back and you see this beautiful planet, and we've checked out the neighborhood. We've got no other place to go. So the beauty of our planet is not just beauty; it's a fragile beauty, and you realize the thinness of the atmosphere. If you think of the Earth as an onion, the top layer, the thin layer of the onion is a relationship between our atmosphere and the rest of the planet. So we need to take care of our planet. And that was, I think, the revelation I had. It might make, well, we all know that, but when you see it, it really drives it home. You see how beautiful it is, and how beautiful it is compared to all the darkness around you, other than the beauty of our planet. And you see the thinness of the atmosphere, you realize we're very, very lucky to be here.
And Mike, there's another question for you right away.
When you saw the planet from Maury, what did you think? But the other thing that I thought, not just the beauty of our planet and the fragility of it, but also the sense that we're all in this together. My concept of home and change when I'm going into space. It really did affect the way I think about my home. When I was a kid, I grew up in New York on Long Island, outside of New York City, and my little town, Franklin Square, that was my home. As I got older and went to college, I think I identified more as a New Yorker. I'm from New York, that's where I'm from. As I went around the country and other places. When I became an astronaut, I wore an American flag on my shoulder, and I'm an American from the United States. But now we have to go into space. I don't think I'm all those things, right? I'm a New Yorker, an American, but I'm also a citizen of the Earth, and I think that's the way I see our planet. That we're all in this together. Whether it's the pandemic or taking care of the environment or trying to get along, we all have the same home. We're all sharing the same place. We might think we're in a different place, but we're really in the same place. We're all on planet Earth. And I think the mission that you're a part of, that Vaisalan is a part of, is international. It's American. It's also European. It's all the different countries that are participating, not just those who are participating to make it happen, but the entire world is going to benefit from what Vaisalan and the rover will do on Mars. And that I think is a way to look at what this project is about. It's about benefiting the whole planet. We're all going to share it. So that changed. When I went around the planet so many times, I realized that is my home. Our home is this planet. And I don't think I had that revelation. I didn't have that revelation until I got to space, but that's how space changed the way I think about our home that we all share.
We've been talking about this now, that we have already Curiosity rover in Mars. We have been examining it and measuring it, and now there's another Perseverance about to be launched to Mars. But when do you think the first manned mission to Mars is actually happening? When is it going to happen? Mike?
The first manned mission to Mars, we've been waiting for that for a long time. I had a friend of mine who became an astronaut long after I became an astronaut in 1996. My friend Kjell Lindgren became an astronaut in 2009, and he flew in space around like 2015 or so, around that time. And he came to New York for a visit. I had left NASA, and he came to visit and give a talk at the school at Columbia and at the Intrepid Museum. And he was telling me they were picking a new astronaut class, and he goes, "Mats, can you believe it? They're saying that this new astronaut class that we picked, ended up picking in 2013, we're going to go to Mars." He goes, "They told us." So actually, this class is coming up in 2017. Because they told us, 6 years ago that we were going to Mars. I go, "Kjell, they told me over 20 years ago I was going to Mars." Let me show you something. This is another jacket I have, right? This is one of my flight jackets. Got my mission patch here. This is a jacket I want to show you that has my class patch. And you can see all the different countries. There's 8 different countries represented, including the United States. And we have a guy from Sweden, my friend Christopher Sprugel saying. So all the different flags are there. But if you look more closely, you'll see a space shuttle and a space station flying there. And you'll see the Earth. And here's the moon. And that red dot, that's Mars. Okay, so we thought we were going to Mars. So I became an astronaut 24 years ago. So we thought someone in my astronaut class was going to get a chance to go to Mars. That's not happening. I think it's still going to be a while, but it's within our grasp. I think especially with the private companies, SpaceX launching people to space now successfully to the space station. I think we're going to see more success with the private companies. And I think countries bonding together, countries of Europe and the U.S. We've been working with the Russians, of course. Lots of countries, Japan, Canada. That's who we work with on the space station. Lots of countries are interested in doing this. China as well. So hopefully we can figure out a way to work together to make this happen. When? We'll see. The answer is always 10 to 15 years. And it's been 10 to 15 years for probably the past 40 years. That's how long it's going to take to get to Mars. But we haven't gotten there yet. But I do think that once we make up our minds to really go, and we've decided we want to go, but it was still a ways away from doing it. I think going back to the moon is a more likely goal to happen in the next 5 to 10 years. And I think that's what we're working toward now. And then I think after we do that, we'll learn a lot and can use that as a springboard to go to Mars. So I'm hoping we're on Mars with people within 15 to 20 years.
Thanks so much, Mike. Well, it's promising to say usually it's 10 to 15 if you don't know. Now Mike gives us 15 to 20. So it's going to be a long while, but it's going to happen eventually. We believe in that. And knowing the humankind, I think they're never going to give up on that quest. So I think eventually we will be setting our feet on the surface of the moon. Hey, time to move on. Now the launch time of this Mars 2020 mission approaches very fast. We have some more weeks before the Atlas rocket will take the rover out of the orbit. What is in your mind right now? Lisa first, feelings, expectations.
It's very exciting. It's good to be involved in something like this. Joining Vaisala for almost 20 years ago, I didn't think I would be involved in a space mission like this, so it's a privilege for sure. And I'm also very proud of the team, our technology science team, together with our sensor factory team, being able to drive the technology so far that we are part of something this unique. So it's definitely a humbling and exciting opportunity.
It's wonderful. And what about Maria Hieta first?
Yeah, I'm really excited, and I have like a positive feeling about the launch and the landing. And it's going to really affect our Mars atmospheric research to have another weather station on the surface. We can do so much more with 2 stations. And 2022 we will have the ExoMars also, so we will have 3 stations on Mars.
Okay, right. Maria.
Well, I'm really confident that the launch will be successful, so I'm actually already looking forward to the landing and all the work that we have to do after the landing, getting all the science data, processing it, and making scientific investigations, writing publications, so that's already on my mind.
That's a really good point that we always think about the launch, but what about the landing?
Yeah.
The launch might go well, and the traveling, making the distance might go well, but the landing?
Yeah, landing is actually much more difficult and much more dangerous than launch.
Right.
So when Curiosity landed, NASA called that the 7 minutes of terror. And I'm sure this will be, again, the same thing. Although the landing technology has already been proven, it's the same technology that is used for Perseverance, so I'm sure it will go well also.
So that's in February 2021.
Yes.
That's when we're going to be
Yes.
biting our nails off.
Yes.
Wow, very, very exciting. Again, how about you, Mike? Are you missing going back there to space? Would you like to go to Mars?
Yes and no. I miss the experience of being in the astronaut office, the camaraderie of my friends. I enjoyed my time in space, the work that goes into it. I really enjoyed that. I missed the whole experience of being an astronaut. But every once in a while, I'll be talking to one of my friends who's still there, and I'm like, well, what are you working on now? And I was talking to my friend Drew Foystel particularly about this, and he was saying he was going in and he was doing an evaluation. He wasn't doing something that I would consider to be fun anymore. He was doing an evaluation of another astronaut. I was like, I remember doing that. So there comes a point, I think, where, 18 years for me and a couple space flights and all the things I got to experience, the Hubble Space Telescope, working in a control center, seeing the space station launch and going through the end of the space shuttle program. We had an accident in it. We lost Columbia. There was a lot of things that happened that I think gave me this wonderful experience, and I felt like, it's time for another challenge. So I do miss it. I would love to go back, but I want to go back if it's easy. I want to go back as a tourist. If I can go back as a tourist where I can kind of show up and get trained on how to use the toilet and then make a meal for a couple, then I'll go. But I think the idea of all the years of training to fly again, I'll pass on that. I'm enjoying what I'm doing now.
And one thing that you're doing now is acting as a professor in Columbia University. How do you see the connection there?
Yeah, I think science exploration at NASA. I loved my job as an astronaut, and so did my colleagues and people who are working on the rover and these other projects are just loving what they're doing. And I think that's great. That all the engineers and scientists. But there's a reason why we're doing this, and the reason is to return the scientific value of what we're going to get from whether it's the shuttle missions or the Mars rover. The reason we do these things is to get that science, that understanding of our world. We learn a lot about Earth. We really go to space to learn about Earth and who we are and how we can make life better on Earth. And also, in this case, going to Mars, of how did we get here? What are the big questions? Why Mars went one direction and Earth went through another in its development. So we want that science return to increase our understanding. When we really don't know what the truth is, we kind of make stuff up. And if you look at history, thousands of years ago, they didn't understand how earthquakes happened, and so they made up a way that happened. The god of earthquakes did that, or Poseidon caused tidal waves, or how the ocean got angry, and all these things we didn't really understand. They didn't understand that back then, thousands of years ago. And looking back to that time, now we understand more about how our Earth works and how important things are for life and so on. We know a lot more. But I think hundreds of years from now, they'll look back at us now after learning all these things of going to space, and we're going to look foolish for some of the things that we think are correct. So we do the best we can, but there's nothing like actually finding out the answers to questions, science questions, that allow us to understand things and take better care of our planet and take better care of each other, so we can continue to thrive as humans on this beautiful planet we have. So I think that's why we go, is to get that information. And I think it's very exciting that Vaisalan, his interest is involved with this project, because I think we're going to learn so much from it that it's going to be a great benefit to the world for many years.
Thanks so much, Mike. And right now, as always, it's too exciting. We could go on forever and ever, but unfortunately, we're soon running out of time, which is right about now. So we have to wrap it up, unfortunately. So thank you, Mike. Once more, you have really, really brought something extra to our show. So thanks so much for joining, sir.
I appreciate that. Thank you.
Thanks also to Maria Genser, Maria Hieta, and Lisa Åström here in the studio for joining us today and sharing your thoughts about the technology and this mission to Mars. This is unbelievable that Finland is involved with something like this so heavily through Vaisalan, through the Meteorological Institute.
Thank you.
That's such a difficult word, isn't it? Meteorological. Meteorological Institute. But however, thanks so much. This has been very, very eye-opening and very exciting for me as well to be able to join you in this very, very exciting times. Next step, getting the rocket up to space. An expected landing, as we spoke, is in February 2021. Stay with us. This was only the beginning of the story. Bye now.